Assalamu alaikum guys. Today we are going to study the unit 2, structure and the bonding. So here we are going to speak about what is mean by the dative covalent bond. Yes, we have studied the type of the covalent bond, right? So what is the name is explain you the dative covalent bond. Yes guys, this is Najmunisha Asha. Today I am going to show you how this dative covalent bond showing the impact on the structure and bonding. Let's move on to the presentation. The content, right? Here we are just going to introduce what is the dative covalent bond, how it's making, and few examples. Along with we are going to study the dative metal complexes. Let's move on to the interaction. I already said, right, when you speak about the covalent bond, right, what is mean by the dative covalent bond? In a molecule or ion, the dative bonds are formed when atom with empty orbitals. You have to be very careful about that. When atom with an empty orbitals interact with atom alone pair of electrons. Simply you can say the dative covalent bond means we have the purple one, right? What is mean by the dative covalent bond? Yes. When you take A and B, one is the empty orbital, another one having what? Yes, the orbital having the atom, the electron is providing its whole pair of electrons to the empty orbital atom. This is what we are calling the dative covalent bond. So the definition should be understood and what we are going to speak through. So why it's happening, how it's happening, this is what we are going to speak here. So let's move on to the presentation. Yes, I said in a molecule or ion, the dative bonds are formed when atoms with empty orbitals, the word is very important, empty orbitals interact with atom with a lone pair of electrons. You should have the extra lone pair of electrons, then only you can provide the electrons to the empty orbital of the atom. In certain cases, when the free atoms of the element have less than 4 valency electrons, should be very careful about that. Though it's having the less than the 4 valency electrons, as like your beryllium boron, the number of covalent bonds that the particular atom can form is less than 4. Yes. So if you should be very careful about that. If it is having the less than 4 means what? The one electron can share from one, another electron can share the another one electron. From that you can form what? The bond. If it is less than 4 means what? You will have the less than 4 bond. If it is a less than 4 bond means you could not aim the octet rule. This is what they are telling is this results in the incomplete octet with lower stability. According to this, what we are speaking here, we are going to we studied about the Lewis structure, and after we are going to study how this Lewis structure shows the impact of the geometry and the shape. So, however, we need the stable configuration. For that, they should have obey the octet rule. In some cases, it's exceeded, it decreases, okay, but the minimum requirement is octet rule is needed, must. Therefore, such electron deficient central atom, what they are doing is they can make less than 4 means they are unable to make what the 8 electrons. That means they are unable to achieve the octet rule. What they are doing is we are calling their electron deficient central atom. Preferably react with the atom having a lone pairs which can donate an electron pair to the central atom to complete the octet. This is what I am explaining. This is what we are telling you. On this line, the electron deficient atom, they need to obtain the octet. That time they are getting a lone pair. Another atom which is having the lone pair, they are donating the electron pair to the central atom to complete the octet rule. This is what is simply shown. Right. So look at here. A is a one atom, B is another atom. So they are telling it's an electron donor. Why? It has the pair of valence electrons available for the bonding. So now it's an atom 2. They have only 6. They need 2 more. What is happening here? This person is providing. He is providing the lone of electron, lone pair of electron, and he is the donor. The A is the donor. The B is what? Acceptor. Ultimately, sharing the valency electrons coming from A, and they will end up with what? The octet. You can count and see here. A is having 8 now, and your B also having the 8 now. Stable compound. You can conclude this is as a stable compound. And we are chilling. You can see this dative bond as the coordinate covalent bond. This is the simple diagram to explain what is meant by the dative covalent bond. How it's happening, what is in such circumstances, what it's accepting, how it's forming the bond, right? And let's move on to the next slide. Here, so we are going to speak about some examples. The first example is the bond between the ammonia NH3 with boron 4 BF3 to form a dative covalent bond between the boron and nitrogen. Who will the electron deficient one? Who should be the donor one? So imagine we said which is unable to make, right, that valence electron. The minimum number, right, the less than the 4 electrons should be the electron deficient one. They need the lone pair. So here you can simply say who is the person is, yes, the boron should be the electron deficient. And the nitrogen, which is the group Y element, they have the extra lone pair to provide the electron deficient atom to form the dative covalent bond. So here, though it's reacting with NH3, BF3, who is going to be a participate here? Nitrogen and the boron. Nitrogen giving, boron is accepting. Other things should be there. This is what the simple structure of this. Right. Okay. So let's we talk about this in a little bit detail. The dative bond is formed when the empty orbitals in B overlaps with the orbital having the lone pair in the nitrogen atom. As said. So how the dative bond? The electron deficient who is having the less than 4 atoms, right? 4 electrons. Sorry, not atom. Electrons, the boron is the one of the person. He is able to overlap that empty orbital with what? Having the lone pair. Who is that? That is the nitrogen atom. In this case, the central atom cannot be chosen to process. So since the lone pair on the nitrogen atom is donating the electron pair to boron, the bond can be donated by an arrow. I said right. If nitrogen is donating the bond, you can be shown in what? The arrow. And this is very important. The arrowhead is pointed towards what? So let's see. formation. And I think I can explain there. So look at here, guys. So he has only 6. He need what? Another 2 to obtain what? The valence electron. Octahedrons. Right? Octahedron. Right. So what you want to do is, you can see here the boron having only 3. They able to make the bond with fluorine. Yes. Now it's had the 6. We need 2. Then these 2, it's donating from what? The nitrogen. Yes, the nitrogen donating to the boron. So the donation of the pair, lone pair, should be shown by an arrow. What is this? The donation of the donation of. Okay, I just want to give me a second. And this could be, this arrow is show what? Of lone pair. And always the head of what? This is another color. Such a very clearly. Yes, the head of, yes, arrow, it shows what? It's pointed towards always electron deficient. Guys, so you should able to see here the nitrogen now it's obtaining the octet. NH3 means what? One from the nitrogen, one from the hydrogen, then they can have 2. So altogether 6, and it has the lone pair, 1 lone pair, that is what? The 8. So ultimately when it's bonded together, it's able to form the bond. This is what? This is why you need to know how to do the structure. According to the Lewis structure, the boron trifluoride is explaining how the nitrogen trihydride, the ammonia, can react with that. Right. And this is what the simple clarification bond formation and so on. So here what is talking about that the lone pair is providing for the electron deficient one. This arrow is what the donation of the electron pair is shown, and these ahead are always projected towards what the boron. Ultimately they will end up with what the nitrogen is provided is a positive and the boron is etc. is a negative. So this is how you have to write the the formula according to the Dative covalent bond. Right. You should be very careful about that. Though this nitrogen having the lone pair, extra lone pair, therefore it's sharing to get the stable configuration with the boron trifluoride BF3. Ammonia we are calling as absolutely the common name. So you can say that is the nitrogen trihydride. So the nitrogen trihydride is able to provide the nitrogen, able to provide the lone pair to the boron trifluorides the boron. It's accepting that lone pair by having the negative and providing the positive. You can see a stable configuration here. So the reaction, next example is the reaction of the ammonia with hydrogen ion H plus to form the dative covalent bond between the nitrogen and the hydrogen. This is very keen and clear diagrammatic formation. So what is happening here? Okay, I don't want to. Okay. So look at here. Yes, you means what is mean by the H plus? There is no any electron, right? So what you want to do is the maximum hydrogen should have. Yes, it should. It's a oneness. If you want to get the stable configuration, you should have the. Sorry. 1s2. What is happening? This nitrogen providing its lone pair to the hydrogen ion H plus. So therefore it will end up with the ammonium ion. Yes, you can see now the hydrogen having 2, nitrogen having 8, and all to this structure can be shown you like that. Nitrogen is providing and the hydrogens are here. And by providing this whole structure can be written as positive charge. This is what reaction is occurring. And simply the diagrammatic formation I have shown. Actually, right, you can see it clearly. This hydrogen, one from the nitrogen, another from the hydrogen, right? This is able to form the 8 electron is there, but the hydrogen doesn't have any electron, therefore it's providing its lone pair and make the stable configuration. You can write like this, right? Either providing the arrow, right? Arrow is always projected towards what the electron potential. This is positive charge. Right. And next, I'm going to speak about what the dative covalent bonds are formed when a metal ions. I'm going to say, yes, I already said. Or some metal atoms react with the molecules or ions having the lone pair water, ammonia, carbon monoxide CO molecule, and the cyanide ion Cn minus in order to form the complex. This is what we have said, dative metal complexes. Should be very careful about that. Here again, right, the metal ions are also able to form the dative covalent bonds. The metal ions also by reacting with such molecules, the water molecule H2O, ammonia NH3, carbon monoxide CO group, and the cyanide Cn minus ions also can be. So let's move on to the example. The formation of the complex when the Cu2 plus the copper ion is reacted with the ammonia molecule, that is the neutral one. Copper is what is meant by the copper? The copper is the metal complex, the metal ion, and this ammonia with 4 ammonia molecules to form the dative covalent bonds. This ammonia is a molecule. By providing this lone pair, can be able to form the dative metal complexes. Simply you can see here what is happening. Yes. So we said, yeah, you have the ammonia. You have 4 ammonia group NH2. It's providing what? It's lone pair, can you see? To the metal ion. Arrow towards it. It's a metal ion. Copper is a metal ion. Ultimately, it end up with what? The formation of the ammonia. Ammonia is a neutral one, right? 0. So therefore, your all metal complex. Dative metal complex end up with charge. That's why we are calling as this is the metal complex, right? So you can write either like this, oh, the copper, right? The providing nitrogen. Square bracket minus, and I will show you this is simpler. You can write this as what? Either like this or like. So there should be what? Should be the arrow or the bond. That is both are accepted. We'll move on to the next example. And take this is what? The hexa aqua copper. So the word is simply explain you, right? Hexa. Hexa means what? 6. Aqua. Okay, I will write. Hexa, aqua, copper, 2, iron. Hexa means what? We have another color. Yes, blue color. Hexa is 6. Aqua means water. Copper 2 ion means CO2 plus. So water is a neutral charge. So the 6 water molecule providing the lone pair which is present in your oxygen and forming what? The octahedron, right? You will study the shape and everything. When a molecule having the 6 coordination bond, such thing. We are telling what? This is the octa. The ligand means what? It's a providing lone pair. We are telling which kind of the arrangement is what? Yes, octahedron. So here you can see the dative bonds using the lone pair, the oxygen, the water ligand is providing to the copper 2 plus. So now you can see 1, 2, 3, 4, 5, 6 small water ligands and forming the coordination number of 6. This is, we are speaking about dative metal complex. And I have given some more the example. Just go through that example and try to understand what is happening in the dative metal complexes. So you can see here the water ligands are there. Ferric is this, here Fe, right? Fe3 plus. It's providing its a lone pair, the water ligands, the water, the lone pair is present in the oxygen. So it's able to provide the lone pair for this ferric ion, and ultimately it's end up with what? The dative metal complex. These all are examples for what? Dative metal complexes. I have completed the dative covalent bond. And the dative covalent bond, we just speak about how the covalent bonds making, the bond making forces, and what is meant by the dative metal complexes. Yes, we have studied about these things. And next chapter, we will speak about how the geometry, shapes, and everything influence in your bond and structure. Until that, see you. Bye bye. Assalamu alaikum warahmatullahi wabarakatuh. Thank you very much, guys.